Development process and human activity have affected environmental quality in many ways. The waste that was produced by human activities are disposed into water or land. With or without proper safeguards will cause serious health impacts through surface and groundwater, land and air pollution, which pose hazards to local people live around the disposal sites.
The landfill in Ampartenang landfill was the site of a case study to determine the impact of pollution sources on soil and groundwater. The Ampartenang landfill site is approximately 4 kilometers south of the hill in Selangor, Malaysia. The site was in operation for about 9 years from 2000 to 2009. The site was once received about 100 tons per day of mainly domestic waste, with the thickness of disposed waste ranges between 4.5 meter and 9 meter.
The site is surrounded by oil palm plantation and situated at low land area at the riverbank about 10 meter from Labu River.
The problem is the deterioration of groundwater quality due to the impact of disposed waste at Ampartenang open tipping is indicated by a considerably high values of electrical conductivity, total dissolved solids, sodium chloride, nitrates, ammonical, and some heavy metals, including iron, manganese, cadmium, lead, and copper. These contaminants have migrated further down gradient of the site as revealed by the results of groundwater analysis. The geophysical investigation conducted revealed that the resistivity value of the decomposed waste is relatively low compared to those of the uncontaminated soil outside the disposal site. The electrical conductivity anomaly on the dumping site was related to leachate plumes, which appear to have seeped at depth as far as 20 meters below the surface. A number of contaminants, including heavy metals, readily penetrated through the formation and eventually reached the groundwater. The short pathway needed for these contaminants before reaching groundwater was enhanced by the periodic water table fluctuation and infiltrating water during the rainy season. The water table is also influenced by the fluctuation of the water level in Labu River. It has been found that soils downstream of the site have been considerably contaminated by heavy metals compared to upstream soil, which is due to the impact of leachate seepage through the underlying soils. The acidic soil environment and the local groundwater flow direction have caused the mobility of this metal, which then is reflected in the elevated concentration of some major contaminants, including heavy metals, in the groundwater. The other problem is the site for Ampartenang landfill was not located at the best possible area, which is very close to the Labu River, which is part of main river tributaries of the Langat River Basin. The surface water from Labu River was used for drinking water and agricultural use. Although the site is located on top of thick natural river alluvium soil, engineered linear materials such as geomembrane, geotextile, and compacted clay should be used. The study revealed that there is a migration of leachate through this clay, probably due to advection and diffusion transport mechanism.
Next is the solution for soil pollution that located in Ampartenang Dengkit. The first solution is the upgrade from open dump to controlled dump site. The site was firstly operated by the city local council before it was transferred under the management of Alam Flora Sdn Bhd. But yet still, the Ampartenang landfill site does not have a proper linear material, except that it is naturally sat on top of thick river alluvium soil. Next solution is management for groundwater and soil contamination. The Environmental Quality Act 1974 was in force since 1975. However, there is no specific regulation regarding groundwater and soil contamination formulated in this act. In 1984, the Malaysian Department of Environment prepared a set of regulations dealing with hazardous waste management. This regulation specifies requirements on the storage, transport, treatment, and disposal of such waste, was enforced in 1989. Legislation is one of the mechanisms which are important in managing groundwater and soil contamination. However, to ensure the duration of mechanism effective, there is need to have effective institutional structure which includes management system and human resources. The need for well-trained monitoring and enforcement officers for effective management of groundwater and soil contamination is critical for effective enforcement. Conducting awareness and education program is an important activity. As a start, Department of Mineral and Geoscience has published a fact sheet about groundwater. The fact sheet provides key information about groundwater and the need to protect its soils which will ensure good quality and sustainable use of the groundwater. Other approach currently being implemented is through reduction of land use for waste disposal. This approach will take some time to achieve its target and will require other activities such as recovery of waste as resources, application of cleaner technology to reduce waste generation, prudent and environmental friendly approach use of chemicals for agriculture use.
Langat basin solid waste disposal are recommended to improve by using incineration. By using this method, it can eliminate the groundwater contamination. Space use will be efficient generation of energy and lower carbon footprint. Incineration also widely used nowadays because of pollution reduction, effectiveness, and aesthetic. By applying incineration at Langat basin, pollution of groundwater and soil will be reduced, including with air pollution and odor.